Welcome to the deep dive. Today we're looking at how databases handle just massive amounts of information, especially when you've got multiple users all trying to make changes at the same time.
Oh, yeah,
It's a tricky problem.
for sure.
And we're going to be diving into a new database system called Aurora DSQL, and it's a really unique approach to managing these situations.
Right.
Our guide today is going to be a blog post by Marc Brooker.
Okay.
He's an engineer at AWS, and he's really up in the world of databases and serverless computing.
Yeah, it's so fascinating how databases make sure that the data stays safe, even when you've got so much activity going on.
Right.
You need a system to keep everything, organized and prevent conflicts.
Uh-huh.
And that's where ACD comes in.
Yeah, I've heard of ACID.
Atomicity, consistency, isolation, and durability.
Big words.
Yeah, so these guarantee that every transaction either happens completely or not at all.
Okay.
The database always stays in a valid state.
Got it.
Changes made by one user don't mess with others. And once a transaction is done, it's permanently stored.
Okay, so ACD is kind of like a set of safeguards to keep our data, safe and sound.
Exactly.
So how does Aurora DSQL actually implement these principles?
Well, Aurora DSQL uses this really clever approach called optimistic concurrency control,
OCC.
or OCC. Yeah, you got it.
Okay.
So think of it like this. Imagine a group project where everyone works independently,
Okay.
and then they merge their contributions at the end.
Right.
OCC assumes there won't be any conflicts
Uh-huh.
and only checks for issues during the merge.
The merge.
Yeah, or the commit phase.
Okay, so it kind of assumes everyone's work will fit together seamlessly.
Right.
And if there are conflicts, then someone needs to kind of redo their part.
Exactly.
Okay, so why is this approach a good fit for DSQL?
Well, OCC is really fast
Okay.
and scalable
Scalable, how so?
by minimizing the need for constant back-and-forth communication.
Between different parts of the system.
Right. It lets you do things more efficiently and handle tons of users and operations all at the same time.
So it's all about letting everyone work independently and efficiently
Yeah,
to avoid those bottlenecks that can happen when everyone needs to constantly check in with each other.
exactly.
But wouldn't this approach kind of increase the risk of conflicts, especially in really high traffic situations?
Like what?
Like buying concert tickets online.
Oh, yeah, sure. But that's where DSQL's architecture comes in.
Okay.
It's designed to handle those situations really well.
Okay, let's break it down then.
So DSQL has several key components.
Right.
The query processor, it handles the initial read and write requests.
Okay.
It plans the changes,
Yeah.
but it doesn't apply them right away.
Got it.
And then you have the adjudicator, which is like a referee
Ah.
checking for conflicts during the commit phase
Uh-huh.
and decides which transactions can actually go ahead.
So it's kind of like having a project manager
Yeah,
and a quality control expert all working together
exactly.
to make sure everything runs smoothly. What happens once a transaction gets the okay from the adjudicator?
Well, that's where the journal comes in.
Okay.
It's a super reliable log that writes down every single committed transaction.
So it's like the official record keeper,
Yeah.
making sure that everything is consistent across the entire system.
Yeah, and then you have the storage replicas.
Oh,
They're copies of the data,
Uh-huh.
and they apply the changes from the journal.
Got it. So it seems like DSQL has this really well-coordinated team working behind the scenes
It does.
to handle all these operations.
Yeah, and Mark also talks about the importance of avoiding hotspots in the database.
Hotspots.
Yeah, could you explain what those are?
Well, I think hotspots are areas in the database that get a ton of write activity,
Yeah, exactly.
and they can create bottlenecks.
Right, it's like 100 people all trying to edit the same paragraph in a document.
Oh, yeah, that sounds like a mess.
Total chaos.
So designing the database to spread out the work and avoid these hotspots,
It's crucial for performance.
especially with OCC.
Right, you want to minimize those conflicts that happen
Yeah.
when multiple users are trying to change the same data.
All at the same time.
Yeah, exactly.
So we've seen how DSQL uses this OCC to handle these write operations efficiently and how its architecture is designed to, manage potential conflicts.
Right.
But you mentioned earlier that DSQL also excels at maintaining consistency and isolation,
Mm-hmm.
even with this optimistic approach.
Right.
So how does it actually achieve that?
Well, DSQL's consistency comes from this clever combo of timestamps and strict transaction ordering.
Okay.
Remember how Marc Brooker mentioned that each transaction gets tagged with a start and commit time?
Right.
These timestamps are super important for keeping everything in sync.
So it's kind of like giving each transaction a unique ID.
Yeah.
And then arranging them chronologically.
Exactly. And here's the key.
Okay.
DSQL's storage system only shows data to a reader when it's absolutely sure it's seen all the transactions committed up to the reader's chosen start time. So this makes sure you always get a consistent snapshot of the data.
Oh, I see. So it's like making sure everyone in a theater is seated before the play starts?
Yeah.
So they don't miss any crucial scenes.
Exactly. No latecomers allowed.
Right. But what happens if, like, new transactions keep coming in?
Yeah.
How does the system know when it's really captured everything up to a certain point?
Right. Especially if the write rate is slow.
Yeah.
That's where it gets a bit more complex.
Okay.
To deal with this, D-Scheme uses this kind of heartbeat-like protocol.
The heartbeat.
Yeah.
Okay.
So the adjudicator,
Those transaction referees we talked about.
right, they commit to moving their commit timestamps forward
Uh-huh.
in sync with the actual clock.
Okay.
And they share this commitment with the storage system.
So it's like a synchronized dance?
Yeah.
With everyone keeping pace to make sure everything stays in order?
Exactly.
This heartbeat system sounds pretty intricate.
It is, but this synchronization is crucial
Yeah.
for guaranteeing consistency and avoiding those latecomer situations.
Right. And remember DSQL's architecture with its separation of components and, its reliance on the journal.
Mm-hmm.
That gives us more than just scalability and consistency and durability.
It does.
We also get that remarkable fault tolerance and availability.
Right.
So if one part of the system goes down,
Yeah.
the whole operation doesn't just crash.
Exactly. There's no single point of failure in DSQL.
Okay.
Data is spread out and replicated, and components are designed to handle failures gracefully.
So it's like having backup generators.
Yeah.
And emergency exits in case of a power outage.
Exactly. Always prepared.
Always prepared.
Right.
This all sounds incredibly robust.
It is.
But earlier you asked about the trade-offs that other database systems might have made.
Mhm.
Since most of them use locking and DSQL chose OCC.
Right.
I'm actually curious to hear more about that.
Yeah, it's a good question to think about.
Yeah.
So while DSQL focuses on scalability and speed and availability through OCC,
Uh-huh.
other systems might have gone in different directions. Maybe putting more emphasis on stricter isolation levels
Okay.
or simpler architectures.
Got it. Yeah.
It all comes down to choosing the best tool for the task.
Right. Each system has its strengths and weaknesses.
Yeah.
Optimized for, certain tasks and workloads.
Exactly.
It's amazing how diverse and intricate the world of databases is.
It really is. It speaks volumes about the ingenuity of the engineers
Right.
who are always pushing the limits of what's possible in data management.
But there's one more crucial piece of the DSQL puzzle we need to look at.
Okay.
It's durability
Right.
and how it ensures that the data stays safe
Yeah.
even when things go wrong.
That's where we'll pick up in part 3.
Welcome back to the final part of our deep dive into Aurora DSQL. We've covered how it handles writes, how it makes sure things are consistent, and how it stays up and running.
Right.
But there's one more piece of that ACT puzzle.
Yeah. Durability.
Durability.
How does DSQL make sure our data is safe even if something goes wrong?
Yeah, how does it do that?
Well, durability is all about making sure data sticks around, even when there are problems.
Okay.
And DE is really good at this,
Uh-huh.
thanks to its unique architecture.
Right.
And the journal.
The journal.
Yeah, remember the journal's like a super reliable log.
Uh-huh.
It keeps track of every committed transaction
Yeah.
to make sure the data is good across the whole system.
So it's like a super meticulous record keeper
Exactly.
who carefully documents every single change.
Right. So there's never any doubt.
No room for error.
Exactly. But the journal is more than just a record keeper.
Okay.
Once something is written to the journal,
Uh-huh.
it's officially committed.
Okay.
Can't be undone.
Got it.
It's a permanent part of the system's history.
So it's really the ultimate source of truth
It is.
for the entire database.
Yeah.
But what happens if something happens to the journal itself?
Well, that's where redundancy comes in.
Okay.
The journal is copied across multiple storage systems.
Uh-huh.
So even if one system goes down, the data is still safe and accessible.
Got it.
It's like having multiple backups of a really important document.
Right. So even if one copy gets lost or damaged.
You still have the information.
Okay, that makes sense. And the storage replicas, they play a part in this too, right?
Oh, absolutely.
How so?
They apply changes from the journal to their own copies of the data.
Right.
But here's the interesting thing.
Okay.
They don't have to talk to each other while they're doing it.
Really?
Yeah, they work independently,
Oh.
reading from the journal and updating their copies.
So they don't need to constantly communicate.
Nope. Makes it much more efficient.
So it's kind of like a team of really skilled scribes,
Yeah.
each working on their own copy of a manuscript,
Uh-huh.
carefully copying from the master copy
Right.
without having to constantly check in with each other.
Exactly. This streamlined approach seems to be a big part of DSQL's design.
It does. DSQL is built to be efficient and tough, and this replication approach is a big part of that.
For sure. It helps DSQL perform well and be resilient.
So it can handle a lot of potential problems without messing up the data.
Exactly.
This deep dive into DSQL has been really eye-opening.
Yeah, it has.
We've learned how it handles writes with OCC,
Right?
ensures consistency and isolation,
Right.
maintains high availability,
Yeah.
and guarantees data durability.
And all while working at scale.
All while working at scale. It's really impressive.
DSQL is a big step forward in database technology.
It really is.
It pushes the boundaries of what we can do with data.
Especially when it comes to managing it efficiently and reliably.
Especially in today's world where data is everything.
It makes you really appreciate the complexity and the ingenuity of the people who built this system.
Absolutely.
And, as we wrap up, I'm left wondering,
What are you wondering?
if this is what we can do today, what might we see in the future of databases?
That's a great question.
As the amount of data keeps growing and getting more complex,
Uh-huh.
we can expect to see even more creative solutions to tackle these new challenges and push the limits even further.
Absolutely.
It's an exciting time to be following the world of databases.
It really is.
There's so much potential for growth and innovation.
For sure.
This has been a fascinating deep dive into Aurora DSQL. Thanks for joining us. We hope you found it as enlightening as we did.